For as long as the Earth has existed, the Moon has been moving away from us. It happens slowly, about 3.8 centimeters per year, a distance so small we never notice it. But this tiny motion shapes almost everything about our planet. So what would happen if the Moon began drifting away? Faster than expected? Not because of anything strange, but simply because of the natural forces that already exist. To understand the answer, we need to understand the relationship between Earth and the Moon. Billions of years ago, both bodies rotated faster. Earth's oceans pulled against the Moon's gravity, creating tides. Those tides acted like a brake, slowing Earth down. And as Earth lost rotational energy, the Moon gained orbital energy, causing it to drift outward. This process still continues today. The Moon moves away, Earth's rotation slows down. Days become slightly longer, just a few milliseconds every century. If this natural process were to speed up, even a little, the first changes would be almost invisible. High tides would weaken. The difference between high and low tide would slowly shrink. Coastal ecosystems built around tidal rhythms would need to adjust. Animals that rely on the Moon's brightness for migration or hunting would change their behavior. Most people would not notice anything, but scientists would see the shift clearly in long-term measurements. Over the next decades, Earth's rotation would continue to slow. The length of a day would increase by measurable amounts. A longer day means a slightly different distribution of sunlight. That changes wind patterns, ocean currents, and even the timing of weather systems. None of these changes would be sudden, they would build up quietly decade by decade. But over time, small differences become large ones. If the Moon drifted away significantly faster over centuries, it would affect Earth's axial tilt, the angle that creates our seasons. Right now, the Moon helps stabilize that tilt. Without its influence, the tilt could wobble more easily. Some years could become warmer or colder than expected. Monsoon patterns could shift. Regions that are stable today could experience new seasonal extremes. Again, these are slow changes spread across generations, but they reshape the world in ways we would eventually notice. At far greater distances, the effects become more dramatic. A weaker Moon means weaker tides. Coastlines evolve differently. Nutrient cycles in the oceans shift. Marine life adapts or disappears. Earth's climate becomes more sensitive to small variations. Eventually, after millions of years, if the Moon continues to drift outward, it may reach a point where it no longer appears the same size in the sky. Total solar eclipses would cease. Only annular eclipses, those with a ring of sunlight, would remain. Humanity would lose one of the most iconic sights in nature. All of these outcomes are based on physics we already understand. No mystery, no anomaly, just the long-term consequences of orbital mechanics. A process that has been happening since the beginning of Earth's history. The Moon will continue to drift away. That part is guaranteed. What changes is how fast it happens and how prepared we are to understand the long-term effects. In the end, the story of the Moon drifting away is not a story of disaster. It's a story of slow transformation. A reminder that even the most stable parts of our world, the tides, the seasons, the length of a day, are shaped by forces that never stop changing. And those changes, however slow, will shape the future Earth just as they have shaped the past.